Comet 3 I/Atlas has recently become an object of significant interest among astronomers, especially after a new image captured by researcher Qiqing Zhang at the Lowell Observatory revealed the interstellar traveler glowing an eye-catching green while appearing to hide its tail from view. This dazzling green hue and the unusual visual behavior sparked curiosity. But researchers are confident that the comet is behaving naturally as it continues its journey through the inner solar system. The observations were made on November 5th using the observatory's powerful Discovery telescope shortly after the comet reappeared from behind the Sun, where it had been temporarily concealed from Earth-based instruments. Its reemergence marks a critical phase of study because interstellar comets are extremely rare and offer scientists a unique opportunity to analyze material formed around other stars. When Zhang captured the latest images, he was able to observe that Comet 3 I/Atlas was glowing most brightly through a green filter, a common feature shared by comets that travel close to the Sun. This green appearance is caused by the coma, the cloud-like envelope of gas and dust that forms around comets as they heat up. As the comet approaches the Sun, solar radiation warms the icy nucleus, causing frozen materials to sublimate directly into gas. These gases expand outward and create a glowing atmosphere that often grows larger and brighter the closer the comet gets to the Sun. The green coloration occurs because many comets release molecules such as diatomic carbon C2, which emit green light when excited by ultraviolet radiation. Zhang specifically used a filter designed to detect these C2 molecules, allowing him to highlight the green emission in great detail. He further explained that comets often carry complex organic molecules rich in carbon and hydrogen. When the comet receives intense ultraviolet rays from the Sun, these molecules break apart. Zhang compared this process humorously to human skin getting sunburned. Just as UV rays damage DNA molecules in our skin, the Sun's ultraviolet energy can break down large carbon-based molecules in a comet. Some of the resulting fragments consist of two carbon atoms bonded together, or diatomic carbon, which glow in a distinct green color that astronomers can easily detect with specialized equipment. This discovery isn't surprising, but it provides valuable insight into the composition and chemical behavior of the comet, reinforcing what scientists know about how solar radiation affects icy bodies traveling through space. An additional point of interest in Zhang's observation is the apparent lack of a visible tail in the latest images. Comets are traditionally known for their dramatic tails, which often stretch millions of miles across space. These tails form when solar wind and radiation pressure push dust and gas away from the comet's nucleus, creating bright, sweeping structures that point away from the Sun. However, in the case of Comet 3 I/Atlas, the new images seem to show no obvious tail, surprising many observers at first glance. Zhang reassured that the tail is absolutely present. It simply appears hidden because of the comet's orientation relative to Earth. According to his analysis, if viewers look closely at the image, they will notice a slight brightness on the left side of the comet's coma compared to the right. This subtle asymmetry is a clue that the tail is positioned nearly directly behind the comet from Earth's perspective, causing it to blend with the coma rather than stretch visibly outward. The tail's true shape becomes clearer once one understands the geometry of the comet's trajectory. Since the comet is moving in a direction that aligns the tail almost straight toward Earth, we are essentially seeing it head-on, which compresses its appearance into a faint glow rather than a dramatic streak across the sky. Zhang explained that the tail curves gently to the left, but this curve is small enough that the structure remains partially hidden behind the nucleus from our point of view. This phenomenon is not uncommon when comets approach or recede from the Sun along certain angles, and it does not indicate anything unusual or problematic about the comet's physical condition. The significance of observing Comet 3 I/Atlas during this phase cannot be understated. Interstellar objects, bodies that originated beyond our solar system, are extremely rare and scientifically invaluable. The only confirmed interstellar comets observed in modern history include 2 I/Borisov and now 3 I/Atlas. Unlike comets born within our solar system, Interstellar comets form around distant stars and spend millions of years traveling through the emptiness between star systems before occasionally passing into new regions like ours. Each interstellar comet carries chemical fingerprints of its birthplace, offering astronomers a rare opportunity to study materials that formed under entirely different cosmic conditions. By analyzing features such as its composition, color, brightness changes, and tail formation, scientists can piece together clues about the environment in which the comet originated. The fact that Comet 3I/Atlas glows strongly in green wavelengths implies that complex organic materials existed in its home stellar system, supporting theories that carbon-rich molecules are widespread throughout the universe. These molecules are fundamental building blocks for life, which makes the study of interstellar comets especially meaningful for researchers interested in cosmic chemistry and the distribution of organic matter across space. Every molecule released, every fragment produced by ultraviolet radiation, and every visible emission from the comet contributes to a broader understanding of how planetary systems form and evolve around distant stars. The presence of diatomic carbon, in particular, suggests that the comet's nucleus contains abundant carbon-bearing compounds, similar to many comets in our own solar system. This similarity hints at universal processes that govern the formation of icy bodies, emphasizing that the building blocks of planets and organic chemistry might be far more common than previously assumed. Moreover, observing how Comet 3I/Atlas behaves as it travels away from the Sun provides valuable information about its physical stability. Comets often become more active as they heat up, sometimes fragmenting or breaking apart if internal pressures become too great. In the case of 3I/Atlas, Zhang's observations indicate that despite its unusual visual orientation, the comet appears stable and active in a normal way. The green glow, consistent with the release of diatomic carbon and other organic gases, suggests the comet is still responding to solar heating and releasing material as expected. The hidden tail, rather than signaling a lack of dust production, simply reflects the angle at which Earth-based telescopes are viewing the comet. As the comet continues its journey, astronomers around the world will be monitoring it closely. Interstellar objects often pass quickly out of view, offering only a short window during which detailed observations can be collected. Each new data point helps scientists refine models of the comet's trajectory, structure, and origins. The coming weeks represent a crucial opportunity to gather more information before the comet fades into the vast dark of interstellar space once again. Zhang's early analysis provides a strong foundation for future research and ensures that astronomers have a clear understanding of what they are observing as the comet evolves in brightness, color, and activity. Ultimately, the fascination with Comet 3I/Atlas lies not just in its stunning green appearance or its seemingly hidden tail, but in what it represents: a rare visitor from another star system, carrying ancient materials formed light years away. Each observation of this interstellar traveler deepens our appreciation of how dynamic and interconnected the universe truly is. The glowing green coma, the subtle tail aligned perfectly behind the nucleus, and the chemical processes shaping its appearance all serve as reminders that even small icy objects can reveal profound truths about the cosmos. Scientists will continue to analyze this remarkable comet, knowing that such opportunities are fleeting and precious, and that each interstellar visitor brings with it a wealth of secrets waiting to be uncovered.